Hi guys, so I'm going to show you how to model the two-step equation using algebra tiles from your review. So first we have 2x, so you're going to want to draw two rectangles for your x's, and it's positive x, so they're not shaded, and then you're going to draw an extra tile, and then you're going to draw your line to show the right side of your equation mat, and you're going to draw 5 boxes. Okay? So again, we have to use algebra tiles to model it and solve it. Doesn't want us to use the numbers, so we have to make sure that we do this whole thing with just the algebra tiles. So again, remember when you're solving a two-step equation, we SAD/MEG. So we do the subtraction or addition first, which means we're going to slash off this one from each side. Okay, and now we're left with the multiplication or the division, so we're going to have to group two positive tiles for every x tile. And so the solution is x is equal to 2, or x is equal to 2. And the way that we're going to prove that is we're going to come over here and we're going to solve it algebraically. We subtract 1 from each side, we get 2x equals 4, then you divide by 2, and x is equal to 2. So these match, so we know we're correct. And just in case you want to check yourself, you can plug it back into the equation, and you get that 5 does in fact equal 5. Okay. So the next one I'm going to do is negative 4x minus 2 equals 6. So again, you want to draw 4 long rectangles for your x's. Except since they're negative x, we have to make sure that we shade them in. And then, of course, we have a positive 2. And then we have to draw our line, and we have to put our negative 6. But since it's negative 6, we're going to have to make sure that we shade those to show that they are negative tiles. Okay. Now, again, we try to SAD/MEG if we can to subtract or add, except I can't cross these off because I don't have positive tiles on this side. So I'm going to have to add a negative tile to each side to try to get this to be a 0 pair and have them go away from the equation. And then I have to get rid of this one, so I have to add another negative tile to each side to have this make another 0 pair and they go away. So once all the addition and subtraction's done, we have to group them, and for every negative tile, I have negative 2. So if we know that one negative tile is equal to 2 negatives, then we also know that a positive tile is equal to 2 positives. So therefore, x is equal to 2. And you can see that by, if you solve the equation, and you subtract 2 from each side, 6 minus a positive 2, leave, change is going to give you negative 4x equals negative 8. You're going to divide by negative 4 on each side, and that's going to leave you with x equals 2, because a negative divided by a negative is a positive. These two match up, so that's great. That's a good sign. And then just to make sure, we're going to plug it back in, and it should be that when you multiply negative 4 times 2 and then add 2 back to it, you get negative 6. That'll give me negative 8 plus a positive 2 should give me negative 6. And indeed, negative 6 is equal to negative 6. The last one is use algebra tiles to model and solve. So we're going to do 3x. Sorry, let me pull this over a little bit. 3x minus 4, so that's the same thing as adding negative 4. So we're going to have our 4 negative tiles on here. And we have to shade them in because they're negative. We have to draw our line that separates them. And we have to draw positive 2 on the other side. Now, in order to solve it, we can't slash them because we have negatives and positives. So in order to get rid of them, we're going to have to add a positive tile to each side. These get together, and they go and run off. They cancel each other out. We're going to have to add another positive tile to each side to get rid of this and make a 0 pair. Then we're going to have to add another positive tile to each side so that those make another 0 pair. And then we'll have to add one last positive tile to each side so that those make a 0 pair. And once you've done all your subtraction addition, you're going to group them, and you will see that one positive x is equal to two positive counters, therefore x is equal to 2. And we're going to make sure that that works by solving it. 3x minus 4 equals 2. If I add 4 to each side, I'm going to get 3x equals 6. I divide by 3 on each side, and x will be equal to 2. And then I'm going to check myself, and I'm going to plug my solution back into the equation. So 3 times 2 minus 4 should give me 2. 3 times 2 is 6, so 6 minus 4 should give me 2. 2 is equal to 2, so we know that the solution works. And then I'm also going to hop back up here to 10, 11, and 12 and just go over them with you. The quotient of a number and 2 increased by 7 is 10. So the quotient of a number and 2, meaning n over 2, increased by 7 is 10. So you subtract 7 on each side. Those cancel, and you're left with n over 2 is equal to 3. Then you multiply by 2 on each side, and you'll get that n is equal to 6. And if you wanted to check yourself, your original equation was this. If you plug it back in, 6 over 2 plus 7 should give you 10. That'll give you 3 plus 7 equals 10, and 10 does equal 10. So you know that you were correct. 8 more than twice a number is 40. So more than, remember, means to switch it, and we're adding. So twice a number plus 8 is 40. So to solve this, we're going to subtract 8 from each side. We'll get 2n equals 32. You're going to divide by 2 on each side, and then n will be equal to 16. To check yourself to make sure that you did it correctly, plug your solution back in. You'll get 2 times 16 plus 8 should be equal to 40. 32 plus 8 should be equal to 40. And we know that 40 is equal to 40, so our solution does indeed work. And the last one is 3/4 of a number minus 6 is equal to 24. So we add 6 to each side. we will get 3/4 n is equal to 30. Now, I'm going to rewrite it up here so I have a little bit more room. If you multiply each side by the reciprocal of 3/4, that would be 4/3. So you multiply each side by 4/3. These cancel, and you'll bring down your n. You put a 1 under the whole number. 30 and 3 have 3 as a factor, so 3 divided by 3 is 1. 30 divided by 3 is 10. 10 times 4 is 40. 1 times 1 is 1, so n is 40 over 1, or n is equal to 40. And then you can check yourself. 3/4 n minus 6 is 24. 3/4 times 40 minus 6 equals 24 over 1. Those cancel to 10 and 1. We know that 3 times 10 is 30. Sorry, I didn't realize you couldn't see that. 1 times 1 is 1, so you have 30 minus 6 gives you 24, and 24 equals 24. And so that works as well. On the front side, a phone company charges $20 a month plus 5 cents for every minute used. Which of the following equations can be used to find the amount of the cell phone bill? Okay, so if it's $20 a month, that's a flat fee for the month plus 5 cents for every minute. So that's 0.05 cents times the amount of minutes. So what equation would fit that? It wouldn't be this one because we're not multiplying 20. This one would work, except we don't have the 20 flat fee per month in there. This one, we're not multiplying by 2 things on each side. But this one works because it's 5 cents per minute plus the $20 for the flat fee means their bill was $60 for the whole month. So A would work. Mark takes 12 minutes to mow the lawn. Which equation could be used to find how many minutes X it would take him to mow 30 or 63 lawns? So if it's 12 minutes per L lawn, you're multiplying 12 times the number of lawns. So therefore, if you mowed 63 lawns, wouldn't it be 12 times 63? And that would give you the number of minutes that it would take him to mow it. So the only possible answer would be B. And then the last one says that May is 10 years old. So May is 10. And it says that her sister June is 2 years older than May. So it's 2 plus 10 because May is 10. Then it says July is twice as old as June. Which equation could be used to find the brother's age, July? So July, remember, was 2 times the amount of June. So July would be equal to 2 times the amount of June, which we just said was 2 plus 10. And that would give me how much Y was. So if we do this math here, we do the distributive property, we're going to get 4 plus 20, which gives me 24 years old. So that's how old he has to be. If we do this one, we're not multiplying, we're multiplying 2 times